Hi, everybody. Thank you so much for being here. My name is Anthony Giuliano, and today I'm going to be talking a little bit about how we can build micro front ends with web components and Stencil. Now, before I get into that, let me quickly introduce myself. Like I said, my name is Anthony Giuliano, and I work at Ionic, a company that is making app development just a bit more accessible for everyone. At Ionic, I work as a developer advocate, and I work specifically on Stencil, a web components compiler. And as you can probably tell from the title of our talk, we're going to be talking a bit about Stencil today. Now, if at the end of the talk you have any questions regarding Stencil, web components, or micro front ends, or anything at all really, feel free to reach out to me on Twitter at that's 2_ Giuliano. All right, enough about me, let's jump on into it. Now, before we start talking about micro front ends, I want to first talk about web app architectures. Kind of look at different architectures, how they evolve and how they scale, and hopefully by doing that, we can come to understand why we even need micro front ends in the first place. So the first kind of architecture I want to look at is this one that we have right here. It's very simple, very straightforward. It's a backend and a front end. The way this works is the backend processes some data and feeds it up to the front end where that data is then rendered to the user in a meaningful way. And that's really all there is to it. Now, as simple as this architecture is, it can be really effective and really useful, especially on a small scale. I'm a big believer in keeping things simple and only making them more complex when you have to, and when you have small-scale apps, this architecture can actually work really well. The trouble is that apps eventually will scale over time as they grow in users and features, and so eventually this monolithic architecture isn't going to really work for us anymore. And the reason being is that if we need to make a change in one part of the app, we're affecting the whole system, and this is going to slow down our builds and our deployments. So we need to make some changes. So what we can do is we can move to microservices. Now, the idea here is that before we had a monolithic backend, and instead what we can do is separate that backend into different microservices, which each represent some kind of functionality that's single and focused in its intent. And in doing so, we now achieve a separation of concerns. What happens here is we're able to work specifically on one piece of functionality, and any changes and deployments aren't connected to any of the other services. So this allows teams to own one piece of functionality and move a bit quicker, not having to worry about how they depend on each other. Now, this is a massive improvement, but it's still not quite where we need to be because if you notice, our front end is still a monolith. And the front end could be small, but eventually I'm sure that our front end is going to grow in size and complexity. And similarly, we're going to need a new architecture. So what do? Well, we take this idea of microservices and we bring it to the front end, and this gives us micro front ends. So the idea here is the exact same idea that we have for microservices on the back end, just bringing this to the front end. The front end also can be separated into different independent features that can be changed and built separate from each other. So we can cut up our front end into these different slices and then compose them all together in a host app or a host page, whatever kind of context is going to bring our features together. Now, what's really great about this micro front end architecture is we get these verticals. And in terms of our team structure, we can now allocate teams for each of those verticals, and each of those teams will own that feature. So for example, if there's some chat functionality, we can have a chat team. We can have a search team for search functionality. Any kind of small feature that we're building in our app, we can have a team for. And that team will then own that feature from the back end to the front end, its complete process. And what's really nice now is, again, we're able to deploy and build separately, so that way these teams don't have to depend on each other and they can make progress much quicker. Now, this is great from an organizational perspective, but one of the other advantages of micro front ends is their reusability. So what we can do is now take these micro front ends and use them or reuse them across different pages of our application. We could even take them and move them to different applications entirely, right? So if you have an e-commerce site and an admin tool and you use a similar search feature in both of those applications, you can take your search micro front end and put it in both instances. Now, that's all really good. I love high-level abstractions for us to kind of understand these concepts, but now I think it's time that we look at a more practical example to understand exactly what micro front ends might look like in the real world. And to do that, we're going to be turning to Google's suite of tools. So hopefully most of you are at least a little familiar with some of Google's products, because we're going to be looking at how we can implement a micro front end in some of their applications. So what we're going to look at first is Gmail. And if you've ever used Gmail or any of Google's suite of tools for that matter, you'll notice that there's this right-hand column that has a few little icons, and each of those icons represent a widget that you can open and then interact with. And so for our example today, we're going to be looking at this calendar widget. It's that first icon on the top there. So what happens is when you click that calendar icon, Gmail will open up this little calendar widget. It will show you your events for the day, and you can also look at event details or add a new event, all kind of within your Gmail app. But obviously this is a very separate feature, and that's what makes it a really good candidate to be a micro front end. So what makes this calendar widget really great as a micro front end candidate is that it's small and independent. And most importantly, it's isolated. And what I mean by that is the calendar widget doesn't really need a lot of context or knowledge of the overall application. It can operate on its own pretty independently with just a few details. So for example, the only thing that our calendar app really needs to know is what user we're dealing with, because at the end of the day, it has to go to some calendar service and fetch events for a specific user. So it'll need to know what user is using Gmail, but after that, it can operate pretty independently. Right, it can display all of the events for the user, it can display event details if we click on one, and if we go and add a new event, it can go and post that event to the calendar service for that specific user. So what's really nice is when we put this calendar widget into Gmail, we only need to exchange a very small bit of information. All right, so we've identified a great candidate, and now it's time to go ahead and build it. And honestly, this isn't going to be that complicated. What I want to stress here is that micro front ends are just an architectural pattern. They're just a way of us to organize our front ends. But at the end of the day, building this micro front end itself isn't really very different from building any other front end application. You can use your front end framework of choice, be it React, Angular, Vue, or Svelte, and you can just build this as you would any other app and then drop it into other pages or applications as we saw with Gmail. So let's pretend that the Gmail app is written in React, and so for our example of the calendar widget, we're also going to use React to build it. So we create a calendar team, like I had mentioned before, and they're going to go to work, and they're going to create a calendar widget after a few weeks. And that's really it. At this point, things are looking pretty good here. So let's now take it one step further. Let's go to a new Google app. In this case, we're going to use Google Slides, and let's try to implement our micro front end there. After all, a lot of the Google apps, like I said, have that side column where we can add a bunch of different widgets. So at this point, we go to implement our micro front end, but we're going to run into a problem, and that is the Google Slides app is written in Angular. And our micro front end, as you remember, is written in React. And as much as I would love this to be the case, we can't just take React components and drop them into an Angular app. So at this point, we have to come up with a different solution. And you might be thinking that we'll have to rewrite our micro front end as an Angular component. And we could do this. This wouldn't be the end of the world, but it would be a lot of duplicate work. And this is just one app, right? We could have other apps like Docs or any other kind of Google Suite tools that are written in Vue or Svelte or some other framework. And in that case, we would have to rewrite our calendar micro front end again and again and again to make it compatible with all of these different apps and different front end frameworks. So at the end of the day, we're going to need a solution that is more framework agnostic. And fortunately, there is an alternative. Enter web components. Web components are a set of web platform APIs that allow us to create custom components. And because these APIs are all native to the web, they can run in any kind of front-end framework. Now, web components are often built to, or often used to build framework agnostic design systems. So you can have small little components that are used in any kind of application. But the benefits of web components are really useful for this idea of micro front ends as well. We can build larger components that act as a micro front end, micro app little widget. Like for example, we can have a calendar widget component, and we get the same benefits of now being able to use it in any kind of app. We can use it in our React Gmail app or our Angular Google Slides app. Now, I know what you're thinking. Stop right there. I'm not using any kind of web components. So maybe you've written web components before, and you may have found the authoring experience to be a little less than enjoyable. Or maybe you're even willing to tolerate web components a little bit, but building micro front ends as web components that could be really complex, that might be a little bit too far. And honestly, I don't entirely disagree with these thoughts. Writing vanilla web components can be a little bit cumbersome, especially for complex applications. But that being said, the benefits of web components are still undeniable. And if we want to find a solution for our framework compatibility issue, we're going to need some kind of framework agnostic implementation. Now, what if I told you that we could actually have the best of both worlds? Enter Stencil. Now, Stencil is a web components compiler that takes the best concepts of those popular front-end frameworks that we know and love and allows us to compile what we write into native web components. Now, we have a ton of features that Stencil offers, things like virtual DOM and async rendering, reactive data binding, TypeScript, JSX, SSG, decorators, props, events, state. We have all of these nice features that we're really familiar with from the front-end frameworks that we know and love. But at the end of the day, we're going to compile what we write down into web components that we can use in a framework agnostic kind of situation. All right, so that's all well and good. Now that we know kind of the problem space that we're facing and how we can go about solving those issues, let's go ahead and do it. Let's look at some code and see exactly how we would build a micro front end with Stencil. Now, this is essentially what we're going for. This is going to be our end product where we have this calendar widget component. And like I said before, we want to have a minimal component API. So in our case, like I said, we only really need that one user ID. And from that, we can pull all of the data and information that we need. So let's go ahead and start building this. When we are building a Stencil component, we're going to start with this component decorator. And now, if you come from the world of Angular, this probably looks really familiar. So there are three things here in our decorator. First, we have our tag, which is just what we want to call our component, in our case, calendar widget. Then we have a style URL that's going to point to some kind of style sheet. It could be CSS, could also be Sass, or whatever kind of styling tools you like to use. And then we're going to set shadow to true. And what that means is that we're telling Stencil we want to use the shadow DOM. Now, the shadow DOM is really powerful. It's really great for web components and putting components in different kinds of applications. But it is a little bit out of the scope of this talk today. So if you're interested in the shadow DOM and want to learn more about it, feel free to go on and check out the Stencil docs. I've written a ton about the shadow DOM over there. All right, so, oh, I skipped one. Here we go. Okay, so we've defined our component, and now it's time to add some props and state and get some data. So the way we do this in Stencil is with decorators. We can just use this prop decorator to declare our user ID that we're taking in, and we can use the state decorator to create an array of events. And as those events change, we'll re-render and update our component. Now, what you'll notice with these two is that we get TypeScript support right out of the box. So I've created this custom calendar event type, and so that way we can type our array of events for some type safety. We can also hook into some lifecycle methods. So for example, connected callback runs when our component is first initialized. And so for our calendar micro front end, what we can do is in the connected callback, just run a simple fetch and go to the calendars API, pull in some events for that user, and then set those events to our event state object. Okay, so we have our props, we have our data, now it's time to render it. For rendering, we use JSX. So again, now if you come from the land of React, this kind of templating will probably look very familiar to you. So what we can do is we can map through our list of events, and then for each of them, just display them. I'm going to do it, pretty simply with some p tags, but we can display things like the name and time and location, and render that however we would see fit. So at this point now, we've done a lot and we kind of have a solid foundation for our micro front end. We're taking in some data from the host app that we're within, but we also need to be able to send some data back out and interact with that app, because as isolated as our micro front end wants to be, it's not going to be completely separated from the host app that it's in. So what I'm going to do is I'm going to create a form for us to create new events in our micro front end. We'll take in the event name, the event time, and location, and then I'm going to be calling this handle submit function when the form is submitted. So that handle submit function isn't too complicated. Essentially what we're doing is we are taking in all of those values and creating a calendar event object from them, and then we're creating a calendar event added custom event. And essentially what this is it is a custom event that you can listen to and operate around when it is fired. So at the end of our handle submit, we're going to call the emit method on that emitter and also attach the calendar event with it, so that way consumers of our micro front end can listen for the calendar event added event and then also accept the calendar event that we pass to them. All right, I know that was a lot. I know it's confusing, but it's really just the start of where we're going with Stencil and how we can build micro front ends. Now, at this point, our micro front end from Stencil's perspective is pretty much ready to go. The only thing is I kind of lied a little bit before when I was talking about web components. Web components are really great in terms of framework interoperability, but unfortunately they're not perfect. In some frameworks, web components are not going to work exactly the way we would want them to right out of the box. What we need to do is add a few different layers and business logic to make sure that our web components work perfectly in any framework that they're used in. And you could do this by hand, but honestly, that process is really difficult and tedious. And so Stencil takes care of that process for you with the idea of framework wrappers. So essentially, we write our Stencil component once, and then we can configure our Stencil project to say that when we build our component, we want to build it in any of these framework front-end framework flavors. So we can build our Stencil component as a core and then wrap it so it works in React, or wrap it so it works in Angular or Vue. And in doing so, we avoid all of those nuances that make working with web components a little bit more difficult. All right, so now we've built our component, we've wrapped it for all of our different front-end frameworks. It's time to deploy. And what's really nice about this deployment process is we can just deploy our micro front end to a CDN. And consumers of our micro front end can pull that down and use it with a simple script tag. It really is as straightforward as that. And what's really nice is we can make changes to our micro front end calendar widget, and the consumers of our apps can wait to consume those changes when they're ready by just adjusting the script tag that they're pulling from. So if we have Gmail written in React and slides written in Angular and docs written in Vue, all of them can pull down their respective front-end flavor from this CDN with a script tag and use it as they want to. So hopefully this has been helpful, and I encourage you to take a look at how you are currently building your apps. Take a look and see if a micro front-end architecture is useful, and then also see if this idea of framework agnostic micro front-ends could be helpful for you and your applications and your teams. Thank you so much.
Hey, thanks so much for watching. I really hope you got some value from that. And by the way, if you want more where that came from, we want to invite you to be a part of our community. Go to composability.dev and register today. If you've already registered, you know what I'm talking about. And by the way, if you're on Twitter at all, go to JavaScript Jam and follow us. Why? Because every Wednesday at 12 p.m. Pacific Standard Time, we go live. Yeah, live on Twitter Spaces. And you can join us and be with us there while we're live. Heck yeah. You know what? And it doesn't matter if you're a beginner or you've been doing this forever. We love everybody being involved. We bring so many people up to the stage. We have so many great conversations. We want you to be a part of it. All right. We'll see you there.